Welcome back. So we're gonna jump into 3.6. In this section, we're gonna talk about asymptotes. This section is gonna help us understand more of the behavior of the function when we look at what's going on, in particular to some special circumstances where the function is approaching infinity, or whether we want to know the behavior of the function at the end of the function, also known as the end behavior. So we'll talk about the horizontal asymptote, the vertical asymptote, and so these are sections that we have covered in college algebra, but we're gonna go and approach these topics in a calculus approach. So let's jump in. So the first one is let's find out the horizontal asymptote. What is the horizontal asymptote? How do we define that in calculus? So let's recall that the limit of a function as x approaches a equals L means that the function becomes arbitrarily close to L as long as x is sufficiently close to a, meaning as x gets close to a, f of x is getting close to L. Now what we're going to do here is we're going to use the same concept. We're going to extend this idea to the limits at infinity, meaning what is happening as x approaches infinity, right? And also negative infinity. All right, so we have an example here that we're going to use to sort of play around with this concept. All right, so let's consider this function, which equals 2 plus 1 over x. As we can be seen in the graph below and the table, the values of x get larger and larger, right? As x gets larger and larger, right? As x goes that way, the value of the function goes down, goes down, goes down, goes down, and is getting closer and closer to the value of 2, right? We can also see it here in this graph. As x gets closer and closer to infinity, right? As x gets bigger and bigger, the values of the function is getting close and closer and closer to 2, right? So this is why we have it, right? We can see that in the picture, but we can also see it on the table. Now let's look at the other side. We can see that as the values of x of the function is going to negative infinity, the values of the function are increasing, 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 and it keeps increasing, increasing, increasing as you move to the left, right? As x gets closer and closer to negative infinity, this keeps getting closer and closer to this y value of 2, right? Y value of 2. So we can see that in our graph as well. Negative 10, negative 100, negative 1000, negative 10,000. The values of the function are getting closer and closer to 2. So we kind of seen this before, right? In the previous, in the earlier chapter, and we can see here that there is a value for which the function is approaching to, whether it is going to the left or to the right. In other words, the function approaches the asymptote y equals 2, right? Remember that we measure y values up and down. So this is the y value of 2. So the function is approaching y equals 2 as x approaches positive infinity or negative infinity, right? It approaches 2. So, and also in the table values of the function f is f is getting closer to 2 as x approaches plus or minus infinity. So there you go, right? So that's how we have defined the asymptote, right? So now let's generalize this. So for any function, we will say that the limit at x goes to infinity of f of x is L if f becomes arbitrarily close to L, as long as x is sufficiently large, right? As x is very, very large as infinity. In that case, we'll say the limit of f of x is L as x approaches infinity. And similarly, we're going to say that for the case where x is approaching negative infinity, f of x is approaching L, f of x becomes arbitrarily close to L. As long as x is less than 0 and the absolute value of x is sufficiently large, right? Meaning that x is going to negative infinity. In the same way, we're going to say, and this is a little typo here that's supposed to say negative infinity here, right? So then we will see the definition of this is going to be a horizontal asymptote. A horizontal asymptote will be that the limit, if the limit of f(x) goes to L as x goes to infinity, or if the limit of f(x) goes to L as x goes to negative infinity, we will say that y equals L is a horizontal asymptote of f of x. All right, and all right. So with the same idea, we're gonna define the vertical asymptote. So let's recall that f of x, the same idea, right? That the limit of f of x can approach infinity, right? Can move towards infinity as x goes to a. Would mean that f is approaching infinity as long as x approaches a. So let's talk about this idea, right? What's going on here? So let's consider the same problem as we can see in the graph and also in the table. As the values of x get closer to 0, as the values of x gets closer to 0, whether it's from the left side or the right side, right? You can see here, let's try with the left side. If as x goes close to 0, from the left side, the values of the function are going down, 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 right? And it's getting negative, more negative, more negative, right? If you notice, if you get x goes closer to 0 from the right side, the values of the function are getting higher and higher, increasing, increasing, without bound. So actually, we have to be a little more careful here, because here we're approaching to different values. So we can see that also in the table, right? As you get closer to 0, as x gets closer to 0 from the left side, the values of the function are getting closer and closer to very negative infinity, right? And if you're coming from the right side, right, as you get closer to 0 from the right side, the numbers of the function are getting bigger and bigger and bigger. So well, what we have here is that this is going to be considered a vertical asymptote, but we gotta be careful here, right? Because in this case, they're not approaching the same infinite. So we have to sort of generalize what's gonna be the proper way to describe this behavior. So we're gonna say that as the limit as x goes to a, f of x is going to approach infinity. We're going to say that that's true if f of x approaches infinity as x approaches a from both the left side and the right side. And we're going to write it like this, right? The limit of f of x is infinity as x approaches a. Or we can say that as x approaches a, f of x is going to be negative infinity. The limit is going to approach negative infinity. F of x approaches negative infinity as x approaches a from both left side and right side. Then the limit of x as x approaches a is going to be negative infinity. So that would be the case that where both are pointing to negative infinity from the left side and the right side, or whether they're both of them are pointing in the positive direction, right? So that's the case. But if that's not the case, where they both are not approaching the same limit, then what we have to do is we have to specify it. And there is a missing a negative here, right there. All right. I think the PDF didn't copy this correctly. All right. So if the limit of x approaches a different infinite as x approaches a from the left side and the right side, then we will specify the limit that corresponds to the direction for which x is approaching a. So for example, if you're coming from the left side, that goes to positive infinity, then we have to, and then if you're coming from the right side and that approaches negative infinity, then we have to specify by telling which direction is the limit coming from. And so we're going to have to use either this combination with that combination or this combination with that combination, right? Anyways, and so the vertical asymptote will be defined as the limit of f of x as approaches positive or negative infinity as x approaches a. Or we're going to say the limit of f of x approaches positive or negative infinity as x approaches a from the right side. or the limit of x approaches positive or negative infinity as x approaches negative a from the negative side. In other words, a vertical asymptote, either the left hand side or the right hand side of the limit function will be either positive or negative, positive infinity or negative infinity. All right, so that's the concept of the vertical asymptote. We will find a different method to find the vertical asymptote in the next examples. All right, so we'll try the next example.